Alright, so today we're doing a GS430. It's a 2000 to 2005. This is for use with a manual gearbox. It's a completely brand new harness and built for a right-hand drive. So let's get into it. Right, so as discussed, it is a GS430 2000-2005. This is for a right-hand drive vehicle. It's got no wiring for the gearbox because he's going for a manual gearbox. He's not using the auto that came originally on the GS430. And obviously we built it completely brand new, so the harness comes inside the vehicle and the ECU now lives inside the vehicle rather than in the engine bay where they did a standard. Right, so what we're going to do now is, first of all, we're going to run through the layout of the entire harness, then we're going to move on to the testing of it. But before we do that, as it's a completely new built harness, I'm going to go through the photos with you now, show you the build process and what it looks like underneath all that heat shrink. So let's do that now and come back in a second. Right, fantastic. So now you know what goes into building these harnesses and what they look like underneath. Let's jump into the layout. And what we're going to do is we're going to start at the ECU end. So nice and simple. You've got 1, 2, 3 plugs. These relate basically to the entire engine harness over there. The only other thing that is attached to the engine harness is the single plug that comes along here and goes directly into your fuse box over there. Okay, so that's that section over there. Over here, we've got what I refer to as the body plugs because they carry all the body instrumentation and connections that are required. So in this case, you can see here, we've got our pedal plug coming out here and it goes into a plug over there, which then goes into a 2-meter plug, which goes into the pedal. In this case, Vince has supplied the pedal for us. This pedal does work with the 3UZ, so along with the normal ones which we recommend, which could be like a Hilux pedal, the later GS430 pedals, the IS220 and 250 pedals. This is another one, so I'm going to give you guys the part number, and that is 78110-02071. Alright, so another pedal to add to the list of pedals that do work with the 3UZ. Right. Other plug that comes out of there goes straight along there and into the fuse box over there. So remember, all of these plugs on the fuse box, they can only go in one spot, so you don't need to worry, you cannot get them in the wrong place. And lastly, you have the 2 plugs over there. One is the 6-pin plug and one is the 9-pin plug. But once we finish going through the layout, we'll pop back in and we'll go through those and explain what all of the wires are that Vince or a customer would have to connect. Right, so coming down along here, you'll see we have our grommets. Now in this case, what you'll notice is we haven't actually shrunk this down. This is so that the customer, in this case Vince or whoever else buys a harness, you guys can then move this grommet up and down to suit your application. Once you've got it in the correct position, then you can heat this down. It's a glue-lined heat shrink on here, so it'll seal it from the environment and make it completely watertight. All right. Up along there, we're going to end up at our molded rear T-piece over here. So this is where the harness splits into the section going towards the front there and making its way there and around the other side. Okay, first thing we're going to do is we're going to come out this side over here, make our way along there down to the bottom, then we'll come back and then we'll go out that section over there. So first thing that pops out over here is coil 7. So remember, this is the left bank, so you're always looking from the back of the engine. So this is left, that is right. You got cylinder 1, 3, 5 and 7, and you got cylinder 2, 4, 6 and 8 over there. Okay, so that is the cylinder orientation. So when you're looking at all the labels that we put on here, that is the order they need to go on. Both the injectors and the coils will be labeled in that way. So it's 1, 3, 5, 7, 2, 4, 6 and 8 over there. Right, so back to here again. So we've got coil 7 coming out there, and you can see everything is labeled for you guys, so you know exactly where it goes. Then what will happen is the harness will come along here. It's going to break out over here, and once it's obviously in its place and mounted, it'll break out close to the cam sensor on this side. So this is a cam sensor for the left bank, and that goes over there. Also ignition 5 and ignition 3 break out at this particular point over here and plug in over there. Coming further along here now, you're going to have another breakout towards the front over here, and that's going to contain the oil control valve that goes in there. It's going to have ignition 1 that goes over there. Then the harness is going to split a little bit, but they're going to sort of run along together for a small section, and then it's going to go off to the cam sensor at the front. You should have a little mounting point here where you can put a sort of like a body clip if you wanted to put a cable tie to hold these tight over there. Coming down the front here, you should have mounting points there, and your harness will clip into there, and that'll keep it away from the fan belt section over here and keep it nice and safe. Once it comes around here, it's then going to split into 3 sections. This section is your lambda sensor plugs. That's for your primary lambda sensor on the left bank. They used to run through there, but it obviously came very close to the exhaust, so we've moved it around to the front here so it can stay well clear of the exhaust, and you don't have to worry about anything getting too hot, including the connector itself in this particular case. All right, then you've got a little thin single wire over here, and again, that's coming through this hole over here, down through there, and it's not going all the way through there in this case. We've obviously got an LS430 motor, so we have the oil filter housing towards the front here. If you've got a GS430 of this particular vintage, your oil housing will be over here. Then this will just come down over here and go over there. We've made this long enough to work in both applications, so if it is LS430, it goes straight down through there, boom, and then into the oil switch over there. If it's a GS430 or an SC430 where you have the front sump, it'll come straight down there and bang into the oil pressure switch, which is going to live over here. Last section that's going to come down is, again, they're going to come through this hole here, and straight to your crank sensor over there. Okay, so those are the 3 sections that break out over there. So what we'll do is we will make our way back over here now, and let's start going around this way over here. So to start off with, we've got 2 earthing points. So they come straight around here and they bolt into the M6 bolt that you should have in the back of your engine over there. So those are those 2. They are labeled ground and ground, so no problems there. Then we've got the injector ACIS sub harness. So effectively this is where all your injectors and your acoustic control induction vacuum solenoid valve come to. What I'll do is I'll put a video up in the top corner. I do have a video on how to install these. These are meant to be installed with the inlet manifold off. Now you do have to take the inlet manifold off to put the other sub harness and obviously your main starter power in there. So when that is all off, this is the time to install it. It also is a good time to check that the vacuum solenoid valve is actually working for the ACIS. We'll go through the test that we're going to carry out now, but you can basically supply power to the ACIS, a vacuum solenoid valve underneath here. Make sure it clicks and that it works. If it doesn't, get it replaced while the intake is off, because otherwise you've got to pull everything off again. All right, but as you'll see here, all of your injectors are coming up through here. They're all plugged in over there, and same thing on that side over there. So they're all coming through there and they're all plugged in over there. So the idea is if you want to pull the whole intake off, you just remove this plug over here. That then frees the entire intake, and it means you don't have to disconnect all of your injectors, which is helpful because with these standard connectors, that's what kills them, the constant taking on and off and on and off and on and off. So if you can limit how much times these get disconnected, that'll be a massive favor. And these DTM connectors, they have a much better cycle life in terms of how many times they can be connected and disconnected. Way better than the standard connectors, so that's the reason why I've done it. Also means that you guys can change injectors if you want to go with aftermarket ECUs. So not only is this obviously separate, so you could change injectors to any style you wanted, phone us up and we can make you another sub harness that'll work with any other style injector. But also the sub harness that goes underneath. So this is the sub harness that goes underneath to the NOx sensors and the starter solenoid. You'll see that we have put 2 twin core shielded cables in here. That means we have the ability to use Bosch wideband NOx sensors rather than the narrow band that comes standard on that. And that is all in the event that you want to upgrade to an aftermarket ECU. Okay, we do have headers for these as well. So in other words, we can make it adapt to whatever ECU you want from there. And obviously we've got spare allocations of unused pins in these terminals, as you will see, so we can add on stuff, things like map sensors, fuel pressure, oil pressure, etc. Okay, so that you don't have to buy another harness if you want to go aftermarket. We can just add to that, and obviously we can adapt that to work with any ECU you want while continuing to work with everything over there. Okay, so those are those 2 sections over there. I'm going to now scoot over to the other side, and then we're going to carry on this one over here. Right, so coming along this side over here, here do we have a little sort of mounting point over here where this little bolt is, and you can put a P-clamp in there and mount that up over there. Then obviously that just mounts up there, and then obviously when you put it through the firewall, that'll keep that upright over there. All right, coming out of here, you've got your ground strap. So again, it's going to the M6 bolt on the top of the head over there. Again, they are labeled G and D for ground, so you should know that they go there. Coming out this side, we've got igniter 8 or coil 8. Coming further along here, we're going to break out exactly like the other side and towards the middle, and we're going to have the cam sensor on the right bank over there, and we're going to have coil 6 and coil 4 coming out there. Obviously, all the injectors are part of that sub harness, so it's nothing to do with this section over here. Coming forwards to the front over here, we've got quite a few things breaking out. So first of all, we've got a little temp wire here. So this is a wire that we add in that allows you guys to put your own temp sensor. If you look down here, you've got the standard coolant temp sensor. Underneath there, you guys will see a bolt that can be removed, and you can put your own temp sensor in there. In this case, I'm just using a 3UZ non-VVT-i temp sensor, and I've just twisted that together because what we're going to do is we're going to use our IS200 clocks and our little device to convert the temperature signal to make sure that that wire is connected correctly and it does work exactly as we expect it to. Okay, so that's number one. Number two, obviously, is the coolant temp sensor itself. So that's a little black plug over there that plugs into that 2-wire sensor there. I do always recommend changing these simply because they do go old and brittle with time, and they're not very expensive, and it's just a useful thing to change, and it may get rid of some issues that you might have in terms of incorrect readings of temperature. Then we've got our throttle sub harness. So again, we've done that so that you can use either a 5 or a 6-speed throttle, depending on what you can get if you ever need to replace it. But more importantly, if you've got an aftermarket ECU, all the wiring is in there pretty much for any drive-by-wire throttle body. So you can have a Bosch, you can have whatever you want and fit it on there. You just unplug this and we can make you a sub harness there. So again, something that you guys then don't have to buy an entire new engine harness. You can basically just adapt it and change the sections as and when you need to do that. All right. Next up, obviously coil number 2. That's the front over there. We're going to be going to the oil control valve for the right bank over there. Then the next breakout is going to come along here, and that's going to go to your mass airflow sensor. You'll see we've given you plenty of room, so whatever you do with the intake piping, you should have no problems with not reaching in this particular case. All right, and the last section is going to break down here, come down here, it's going to split up towards your alternator, and you're going to have your separate alternator sub harness. So again, same principle, because of the later generations had a 4-pin plug and these have a 3-pin plug, we've separated it so that if you can only get your hands on a later generation alternator, just phone us up, we'll make you a sub harness just for the 4-pin plug, and you can unplug this, plug that one in, and put a high amperage 4 one from like a GS430 from 05 to 07. All right, then the last section is coming down here, and it's going to the lambda sensor on this one here. So again, we're only using the primary lambda sensors. So these are the ones that actually control the fueling. The secondary ones after the cats, they get remapped out of the ECU, so you don't need to worry about them. They're no longer in the software, they're no longer looked for, and most importantly, they no longer give you an error code, which is the important part there. Okay, so that's the entire layout. Everything is labeled, but the video should help you know exactly where everything is going. But it is relatively straightforward. Because it's right-hand drive, your T-piece is going to be on the left bank over here, because everything's going to make its way into the passenger side of the vehicle. Then it's just going to make its way around the engine there and down that side, and again along here and down there. Obviously, you've got your sub harnesses for your throttle, so you see your 2-pin plug there, your 4-pin plug there. That can just tuck away underneath over there, get out of the way of everything, and plug in over there. So again, in terms of the inlet manifold, obviously you do have coolant lines here, which you guys are probably going to attach. And so if you wanted to, but you could unplug the throttle from the engine harness, and you could unplug the intake from the engine harness just with these 2 plugs and effectively remove the whole thing off as one unit and go ahead and replace the starter, do whatever you want to underneath there. Nice and easy, and you don't have to disconnect all of these standard connectors, which have a tendency to break if you just keep on disconnecting and connecting, disconnecting and connecting. All right. So what we're going to do now is make our way to the client plugs. So client plugs, basically these are the ones that the customer, in this case Vince, is going to wire into his car. There are only 4 actually to get it running, in fairness, but I'll go through everything that we do give you, because obviously we give you indication lights, etc, etc. All right, so 9-pin plug, that is your main one. The 6-pin plug has basically just got the OBD2 plug in, so that's for all your live diagnostics, and the brake switch. So now with the manuals, to get your deceleration fueling all correct, we are now actually fitting a brake switch relay to imitate exactly what Toyota did with the brake switch there. So we'll go through that in a minute. But starting with a 9-pin plug, really nice and simple. We've got pin number 1, that is a red 14 gauge wire, and that is a permanent 12 volt supply. So the reason it's permanent 12 volt supply is the ECU stores codes when it has errors. If you connect the red wire to an ignition 12 volt source, what's going to happen is every time you turn the ignition off, you're going to reset the ECU. And if you're trying to do diagnostics, you're going to be pulling your hair out, because every time you turn off the key, it's going to reset and erase all the codes, and you're not going to be able to get the old codes. And yeah, it's just a nightmare. So please, permanent 12 volts, not an ignition 12 volt source on that particular wire. Okay. Pin number 2 is black and yellow, and that's your start signal. Again, very simple. It's literally just starting with 12 volts. So we've done it like that because most key barrels, if you're using a key barrel, obviously would provide 12 volts when you go to start position. You can also then just use a switch with a 12 volt source. Now do remember that these are going and they are controlling relays, which are actually controlling the high currents. So these ones could literally be 22 gauge wire or 0.35 millimeter squared if you use that particular measurement. So they're not carrying any serious current, so you could pretty much use any switch you wanted to with a 12 volt on the other side, and that could be your start button, or you can use your ignition barrel as per normal, and that will then be your start button there. All the signals going to the ECU in relation to starting are fused inside the fuse box, so that system is fully protected from there. Okay. Number 3 is yellow and green, and that is gauge temp. So that's what I was talking about over here. That's the one I've got twisted there temporarily to test. So that one, you can put your own temp sensor in, you can wire it up to that single wire, and it'll come out here on the yellow and green one, and you can take it into your dash or your cluster or your little gauge. Maybe you bought a separate gauge on its own. That will all work through there. Okay. Number 4 is gray, so that's a 16 gauge wire. That is your fuel pump. So the actual fuse box in this case is controlling the fuel pump. I'm going to put a link up in the top to tell you how to control fuel pumps, and what you'll notice is a GS used a fuel pump ECU to control the speed of the pump. So in this case, what we've done is we've kind of replicated more of the LS430 and etc. So A, she doesn't prime. B, she's controlled via the oil light. So in other words, if your oil light is on, it will kill the pump. The pump will only get power when you crank it, and it'll stay powered as long as the oil light is out. As soon as the oil light goes on, it will obviously then kill the pump. If you don't connect your oil pressure switch before connecting the fuse box and you turn the ignition on, the fuel pump will run, because obviously the oil light will technically be off because you haven't got it connected. Okay. So if you turn the ignition on and the fuel pump just starts running all the time, that's more than likely the reason why, that your oil pressure switch is either not working or your engine block is not earthed properly, so it's not getting earth through the oil switch. So do check that out. That's what will happen in the event of that happening. Right, number 5 is yellow and red. That is your check engine light. So in this case, you'll see here we've actually got it hooked up to our dash. So we're going to have our check engine light when we put the ignition on. We've also got an LED inside the fuse box. That is a check engine light. So that's to help you guys if you want to get it started with just connecting those 4 wires on the bench or something, then at least you can have that check engine light to know that everything is turning on, the system is activated, and there you can feel free to go ahead and start it. Okay. Most importantly, that check engine light provides a ground. So if you are using an LED or a dash or anything like that, please make sure that you connect to the ground side of the light, not the 12 volts. Otherwise, nothing's going to happen there. All right, number 6 is a yellow wire. That is your tacho feed. So the tacho feed or rev counter feed comes from the ECU itself. It is a 4-cylinder feed, and it's what we call an ignition negative pulse, just in case you are buying any sort of gauges to work from there. Little tip on the older vehicles where you used to have the coil firing the rev counter or tacho. Usually they actually used to have, well, specifically in Toyota vehicles, I know, I can't speak for every other vehicle, but they usually used to have a resistor inside the back of the cluster to actually condition down what we call the high level signal that an igniter would give out. So if you guys are doing these sort of swaps and you're using this instead of like a really old Toyota, little trick, go to the back of the dash, find the tacho feed, find the resistor that's in there, remove it, use a piece of wire to bridge where the resistor was, and these low-level signals that come from an ECU, they should work on Toyota dashes, no problem at all. Just a little tip for you guys there. All right, number 7, black with a red tracer, and that is ignition. Now then, something I want to say, and I have seen it, it may sound stupid, but I have seen it before. When you use an ignition barrel, there's two feeds. You have accessory and you have ignition. What's important to know is that accessory cuts out when you go to crank, all right? So the same way when you get in your car and you turn it from ignition to crank, you'll notice that your radio shuts down and all that type of stuff. Those are circuits connected to the accessory feed. They're designed to shut down to allow the starter motor to pull the most amps from the battery without being hindered by things like radios and etc. All of that being powered up at the same time. So why is that important? If you connect this black with the red wire to the accessory feed, what's going to happen when you go to start? It's going to shut the ECU down and it's going to cut power to that. So when you are looking for these feeds, especially on an ignition barrel, make sure that when you find the 12 volts, make sure you turn the key to cranking and make sure that that 12 volts stays on that wire and use that as the ignition wire for this one. If you find a 12 volt wire but you lose this 12 volts when you go to start, accessory feed not suitable for this one. Okay, I have had it happen way more than once in the past, so I do like to highlight that for you guys. Sometimes it's just a silly mistake and it's something it happens to anybody, so again, but just a little reminder for you guys for that one. Right, number 8 is pink with a blue tracer. That is your charge light. In this case, I've actually got it hooked up to an LED over there. Now, what I mean by charge light, basically it's your alternator light. It comes from the alternator itself, and it's what you use on your dash to have your little battery light on, and obviously when you start the car, that goes off. Now then, another thing that I've come across before that's really, really important. Basically, on these particular vehicles, yes, the alternator light usually went to the ECU and communicated via MPX to the dash. Why is that important? Well, basically, even the generations before where the battery light did go to the cluster, they used to use LEDs. Now that's important because that means that the cluster can't backfeed into the alternator, keeping the regulator on, or in some cases, in a worst case scenario, I've had complete fuse boxes staying on afterwards. So if you have an old dash with an incandescent bulb, either replace it with an LED bulb. That is your best solution because that LED bulb will then stop any lot of backfeed because LED is a diode. Or you can fit a diode in between my pink with the blue wire and the back of your cluster, which would then effectively stop the flow and would not allow backfeeding into the system. So please just keep that in mind when you are doing that. Because again, like I said, I've had worst case scenarios where the cluster was backfeeding all the way into the system, was actually keeping the fuse box alive when you turn the ignition off. Okay. Then the last one, number 9, that's a yellow with a black tracer, and that is your oil pressure. So again, oil pressure light, nice and simple. In this case, our black with the yellow is actually connected to our device, and you can actually see on the cluster here, we've already got our oil light active because this has got a permanent 12 volt supply over here, so that's absolutely fine. Right, so that's your 9-pin plug. So you can see you only need 4 wires technically. Red, permanent 12 volts, gray, fuel pump, black and red, ignition, black and yellow start signal. Those are the only 4 you need. We've done your pedal already. It'll plug straight into your pedal. If you have a harness done by us, it'll be all like this. So again, 4 wires. The other ones are basically just things like gauge temp, check engine light, tacho, charge light, oil pressure, things that you don't have to connect, but it's nice to have on the dash, especially things like a check engine light. Then you know when you've got a problem coming on. We do remap the ECUs to get rid of all the codes. So when we come to the testing, you'll see that even though this has got no auto box connected to it and it is a 3UZ ECU, it's going to have 0 codes, no codes at all in relation to this. So you can hook your check engine light with confidence to know that if your light does come on, you do genuinely have a problem that you need to rectify and the vehicle will be in limp mode. Okay. Coming to the 6-pin plug, this is really, really simple. Basically, the first 4 wires are just for your OBD connector. Okay. And your 5th one is a white with a blue tracer, and that's your brake switch. So all it basically is, this ECU on the 3UZs require 2 signals in relation to the brakes. One to know when the brakes are not pressed and one to know when they are pressed. It's a redundancy to go from there. So we've taken care of all of that inside the fuse box. All you guys have to do is supply your 12 volts to your brake light switch. Now, you don't have to connect that. Appreciate it. It will work without that being connected, but we have with the remaps now sorted all out to get rid of the auto box. So now all your deceleration, fueling and so on will be correct if you do connect that. So I do highly advise you to connect that. But again, you don't have to. I will leave it in your capable hands. You guys can make the decision from there. All right, so those are all the plugs that are going to be there, and that again, Vince, you will get this. I'll email this to you so you have a copy of this, and we keep a copy of every customer's harness, complete build with photographs and everything, basically for life. So if you guys ever lose this stuff, please feel free. You can just give us a shout and we'll send it out to you. Right, so next up we're going to be doing the testing. So that involves actually starting of the engine. So what I'm going to do now is I'm going to get it all nicely warmed up so you can see things like the temperature gauge and everything working. Once I've done that, we'll come back, we'll go through all the tests that we're going to carry out, and we'll actually get them done. So give me a second while I get that all sorted out, and I'll be back with you guys. Right, so now we're going to move into the testing, and first thing I'm going to do is I'm going to go through the list of tests that we are going to carry out on this particular harness. Then we'll just get into doing the testing. So let's start with the list down here. What are we looking at? First of all, we're going to look at the check engine light. So again, we're going to put the ignition on. We're going to make sure the LED comes on inside the fuse box. We're going to make sure the check engine light comes on the dash. That tells me that both this wire and the actual fuse box are working. Then we're going to check the oil pressure light. Well, we've kind of already got it, but what we'll be looking for mainly is when we start it, it'll turn off to indicate that it is actually working. Alternator light. Once you put the ignition on, one of these LEDs is going to light up. That's going to indicate to me the alternator light is working. And when we start it, you're going to see that those are going to go out along with the oil light and the check engine light to make sure that everything is working as it should do. Brake switch. So what I'm going to do is I'm going to supply the brake switch with 12 volts, which is what your brake switch would do, basically the feed for your brake lights. And then we're going to check on the OBD2 machine, and that's going to show us that the brake light is actually turning on and off when you power that button up over there. Then we're going to look at the OBD2 machine, while at the same time, and obviously show that that is working and communicating with the harness, and it's obviously plugged in over there. Then we're going to look at the fuel pump, which obviously what I'll do is I'll just briefly crank it, and then you'll actually hear the fuel pump running. It'll be a little bit difficult, I do appreciate that, but obviously we'll do that. And then when we start the vehicle, you'll actually see that the engine fuel pump is actually running exactly as we expect it to. What I might actually do as well, thinking about it, is I may actually just disconnect the oil pressure switch to show you guys that the pump will just turn on automatically as soon as the oil light goes off. It's another way of showing you guys that it's working. Right, then we're going to move on to the actual engine starting. And once we've started it, what we're going to be looking at, first of all, we'll sort of recap that, and we'll go back and make sure all our lights go off. That's nice and easy. Then we're going to make sure that the tach works. So while we're there, we'll take a look. And basically what we're doing is we're using our little device here to take the tach feed from the ECU. We're converting it from 4-cylinder to 6-cylinder, which is what this cluster is looking for. And so we should have a nice accurate tacho feed on there. Then we're going to look at the temp gauge. So, well, because it's got a permanent feed, you can actually already see that the temp gauge is reading correctly, and it's actually going up and down. So I'm quite happy with that. So again, a little bit premature on that, unfortunately. Then we're going to look at the ACIS. So this is the ACIS system. What I'm going to do is I'm going to put a video in the top corner here explaining exactly how that works and what it does. But what I will do is, effectively, what I'm looking for is that valve to open as soon as I start the vehicle up. All right? That'll show me that the ACIS is working as we expect it to. Drive-by-wire, a nice simple test. Because it's full drive-by-wire, we're just going to press the accelerator and engine needs to rev. Simple as that. VVT-i solenoids. So what we can do via the OBD2 machine, the sort of intelligent Toyota tester, is I can test both oil control valves. That's these things over here to make sure they are working correctly. So that's making sure that all the wiring in there is 100%. Also a little tip for you guys. If you've got a cool tester like this, there's filters inside these particular cam covers over here at the end that obviously filter the oil for the VVT-i solenoids. So do bear in mind, those filters can get clogged up. So if you've got a particularly bad engine, so if you pull this cam cover off, for instance, and it's just absolutely filled with sludge, might be worthwhile pulling this off and just cleaning out that filter just to make sure that your VVT-i valves are actually getting a good flow of clean oil. Just a little warning for you guys, if you pull this cam cover off, this cam cover will be much dirtier than that side, and there's a very simple reason for it. This pipe over here normally connects over here. So what you're basically doing is you're taking the vacuum from the intake and you're pulling the crankcase through there. That's why these inlet manifolds get full of oil. So if you ever pulled one apart before, you'll see like a puddle of oil all in them. That's where it's coming from. It's just pulling the PCV through there, and then it's letting oil condensate inside the valve itself. So what that basically means is this pipe over here, which normally connects to here in the standard vehicle, that's where it's getting air from to pull out over to here. So effectively all of the crap in the engine that's being sucked out is being sucked out through this cylinder head. So that's why these are so dirty compared to these. So sometimes you open up these and they look like a brand new engine. You open up this and it's just full of oil staining and, you know, brown and all that type of jazz. It's not a problem. That's just the way it is. If you guys want to obviously rectify that, you can clean everything out. Then the only option in reality is obviously to run through an oil catch can so you can catch the oil from there. but then obviously you're still going to have the system of sucking air through and actually coming through and then coming through this side over here, which is going to make it dirty. So I suppose in reality there's not really much else you can do apart from just putting filters on here, and therefore you've got no physical suction coming through, so therefore neither side will get dirtier than the other effectively. All right, up to you guys, leave it up to you. All right, so that's the VVT-i solenoids. Then what I'm going to do is I'm going to unplug each injector at a time. That's just going to basically show that the engine's going to run completely smooth while it's idling. As I pull each one out, it's effectively going to start misfiring. So I know that each and every cylinder is firing exactly as it should do. If anything was wired wrong, we'd hear it and it would be misfiring like mad because these are fully sequential engines. Okay. Then the last thing is the code. So basically we're going to jump into the machine. We're going to show you that it's no codes. Obviously you will notice that the check engine light is going to turn off while it's running, but we will show on the machine that there are no codes. So again, as I said before, you guys can feel free to connect your check engine light up because you should have no check engine light unless there is something genuinely wrong. Right, so let's get into the actual testing itself. So what we're going to do is we're going to turn it on. So as per the last one, as per the layout, it's a black with a red tracer. I'm just going to feed that with 12 volts, so bear with me a second. Okay, so you can hear the relays all activating. Okay, so let's go back to our list. So check engine light, you can see we've got our LED over there. You can see we've got our check engine light on our dash. Super happy with that. Oil pressure light, well, we've already seen that it's on. Alternator light, now we can actually see that one of the LEDs are powered up on there, so that's all good. Right, brake switch. So what we'll do is we'll kill two birds with one stone. We're effectively going to go into the OBD2 machine and make sure that's working. So you can see I'm actually seeing live data, 52 degrees coolant, 19 intake, 15% throttle. So what I'm going to do now is I'm going to go straight down here. We're going to find stop switch. Stop light switch is currently off. So all I'm going to do is supply this white with the blue with 12 volts. And you can hear the relay clicking. Okay, so as I do that, let's just go over to stop light switch. There you go, it's on, let go, and it turns off. So that's working exactly as I expected to. Obviously the OBD2 machine works. We'll just go into function, we'll go into system select, and you'll see it's picking up as GS430. Okay, so I'm going to go back into the live data. Right, so fuel pump. I think what I'm going to do is I'm just going to disconnect the oil pressure switch just so you can actually hear the fuel pump activating, because otherwise if I crank it, you're not going to hear anything over the engine cranking over. Right, so nice and simple, if I just disconnect this, and as I do it, I'm just going to go over here, and you can actually hear it in here. Okay, so as I said, if that's not connected and your engine block is not earthed, that's just going to happen when you turn the ignition on. Your fuel pump's just going to constantly run. So do make sure that's connected. And obviously we built it in as a safety for you guys. So if you lose oil pressure, engine fuel pump will shut off and the engine will turn off. Right, so that's everything on the ignition side. Now we're going to start it up. So what we're going to do is start her up. We're going to go over to the dash quickly. Hopefully you're going to see that our oil light, our check engine light turns out completely. So we know that's 100%. Then we'll look at the tack, make sure that we're actually getting a tacho signal through, so I'm happy with that. And the temp gauge, well, that's already rising, so I'm happy with that, so no major issue there. Then what we'll do is we'll come over, check the ACIS valve, make sure that's working. We'll then go over and we'll rev the engine from the pedal, testing the drive-by-wire. We'll then go into the machine, test the two oil control valves, and as you'll hear, basically what it does is it retards the cams, so effectively it just sounds like a really lumpy cam engine. But you're going to hear that change in engine tone when I do it on each one, so I do each bank individually. We'll go through the jettison coils, pull one out at a time, and then we should get a misfire each time we do that, and then we'll come back and look at the codes. All right, so to start it, really nice and simple, black with the yellow tracer, give it 12 volts, 1, 2, 3. Right, so let's go over, and you can see we've got a tack signal coming through there. We've got our temp gauge working over there. You can see that that valve has moved down, so that's all perfect. Drive-by-wire, just going to give it a bit of a rev. Right, so that's nice and working. Right, VVT-i solenoids. So we're going to go into active test. We're going to go down to VVT-i control bank 1. so you can see we have 0 codes on there. Okay, so I'm going to kill it. Okay, what you'll notice as well is the fuel pump will keep running even though you turn the ignition off, and that's because the ECU keeps the system alive for a few seconds afterwards, so it's completely normal. Don't freak out about that. Right, so let's put the ignition back on so you can see everything coming back to life. Right, so you can see all the check engine lights and everything coming back on. We obviously saw them turn off. We've taken a look at the machine here, and you can see straight away we've got absolutely 0 codes. There are 0 error codes, even though there is no gearbox connected, even though there is no secondary lambda connectors, 0 codes. So again, guys, feel free, connect that check engine light. It's super helpful. Make sure you get permanent 12 volts on there so you can store the codes when you go and check it. And also, we have built in to the actual OBD2 plug, right, the ability to put it into diagnostic mode. So unfortunately with the 3UZs, you can't bridge the 2 terminals like you would normally. So basically, in our case, it's pin 5 and 13. In order to flash the check engine light, that functionality has disappeared from European and US models. JDM models, you can still do that. You can still flash it like an old school system with the Morse code lights, but European and US, unfortunately, you cannot. Right, but why would you do that? Number one, if you can put it in diagnostic mode, what's super important is you can check timing. So if you look down here on your engine, you see you've got 0, 5, 10, and 15 degrees. You should also have a marking on your crank, which guaranteed I'm not gonna find now, obviously. Anyway, there is a V marking in your crank. Okay, I suggest you get some sort of, I call it Tipex, some people call it correction fluid, white paint, and you just mark it out there and you should be able to see it. So basically, if you put the system into diagnostic mode by bridging pin 5 and 13, in our case on our OBD2 plug, then what you'll do is you'll lock the timing at 10 degrees, which means you can check the timing with a timing light by basically putting your clamp around. If your timing light works by putting the clamp just around the wiring, which some do, like my Sealy does, then you can check the timing without having to take any covers off. Just clamp it on there. Bridge 5 and 13 on our OBD2 port. It'll lock it at 10 degrees and go from there. Obviously, please make sure you don't leave it locked in with the bridge, because otherwise the engine will lock at 10 degrees and you're gonna have no power, etc. the whole way through. All right. But like I said, 0 codes on there. We've remapped everything out. Now, also, this does have a slight improvement in power. The throttle response is greatly improved as well, so it doesn't feel as lazy as it does in the normal vehicle. And obviously, with remapping all of the gearbox codes out, she's in no limp mode and she's running exactly as she should be, as if everything was completely normal and she was BOGO standard, okay? With those slight tweaks that we obviously carry out from there. Right, so that is everything tested. What I need to do now is get this off the engine and in a box and over to Vince so he can get his vehicle done. Vince, if you do have any questions, again, feel free to message us. Obviously, we'll get back to you as soon as we possibly can. You will be getting the full welcome pack with everything labeled down there. Like I said, I do keep copies of everything, so if you do lose anything, feel free to contact me and I can supply you with anything. That's just a tip for some other guys. We do get our harnesses being sold onto other people. Please bearing in mind, we only work with people's names. So if you buy a vehicle with one of our harnesses in, do make sure to get the guy's full name. That's his first name and his surname. We have got literally hundreds of customers. So if you say, I bought it from a Matthew, I could probably pull up 20 Matthews that we've done harnesses for. So if you pull up their name and you phone me or message me, I can move all of the documentation over to your name. And if you have any problems, you can phone us and then we can help you out. So just a quick tip, if you do buy one of our harnesses, please make sure you get the guy you're buying from full name. Let us know. We'll update the details on our system to make sure that that harness is then associated with you. We do it with people because obviously these particular harnesses can go into a lot of variations of vehicles. And so things like registration numbers just wouldn't work in this case. The best defining factor that we can have is a customer's full name. Okay, so that's just quickly, because we are getting a lot of people phoning up going, I bought from such and such, or I've got your harness and we're having this problem, and I've got to go, all right, well, who did you buy it from? Then I got to find all the paperwork. So just a little tip for you guys, if you guys do want to keep everything updated, please do that, and we can move all the files and everything over to your name from the old guy's name or girl's name, and then we can then help you out in the future anytime you give us a call with that. All right, but if you guys have any questions, do bearing in mind, this is obviously right-hand drive. We can do left-hand drive. That's no problem at all. What we are possibly considering in the future is when we do these harnesses straight off the bat for aftermarket ECUs, what we are starting to do is put a sub harness in for the coils. So there is actually a 3UZ on a ECU Master Black. If you want to go look at that video, I'll put a link up there. You'll see what I mean by the sub harness with all the coils on, so you guys can change coils. But what I can do as well is we do have the ability to start adding in things. So if you guys want, we can start putting a 6-pin plug down here at the bottom that would allow you to do oil pressure and temperature. We can start to put a 4-pin plug at the back that would allow you to do fuel pressure and temperature. We can also then bring out a sort of 3-pin plug at the back here for a map sensor. So what we're asking you guys now is, if you want, let us know. We can make these much more compatible with going an aftermarket ECU while still being able to function fully on standard management ECU. So again, I need your guys' opinions. Would you like us to do that? Would you like us to make these harnesses for standard management much more friendly to aftermarket when you guys want to upgrade? Or do you think we should just leave it the way it is, and then we can then just do the updates as and when and add things into there rather than add them in from the beginning? Please let us know before we obviously spend some time in development with that. But yeah, thanks for watching, guys. If you have any questions, comments, please leave them down below. Again, we're always looking for suggestions of videos to do technical stuff on. I do throw in bits, you know, when I'm busy doing a harness like this. And then what I'll do is, if you guys message me with something that you want to know, then we will try and do a video and explain it in much more detail. But thanks for watching, guys. We'll see you again later. Bye-bye.
So high I'm hypnotized. What's up is down, what's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through.